So the number of people who visit this Leftorium store in a day is distributed Poisson 100. So lambda equal 100. We are assuming that 10% of the customers are sinister or left-handed and 90% are dexterous, right-handed. Half of the sinister customers make a purchase, but only a third of the right-handed people make a purchase. The characteristics and behavior of people are independent, with the probabilities described in the previous two sentences. Okay. Then on a certain day, there are 42 people who arrive at the store but leave without making any purchase. Given this information, what is the conditional PMF of the number of customers on that day who make a purchase? Okay, so this here is a problem which is clearly sort of a chicken and egg type of situation, but let's start by just writing carefully out all the information that we know. And what we start with is that we can denote n is the number of people that visit this store, and that is Poisson with lambda equal 100. And we can let x be the number of people who visit. So these are the people who visit and make a purchase, and y the number of people who visit but don't make a purchase. So visit and buy, visit and do not buy. Okay, and so we know that n equals the number of people who visit and buy and the number of people who visit and don't buy. And conditioning on the information that if we know n, we also know that this x is a binomial with the parameter n, probability of p, right? We know that those are the probability of buying. We also know that y conditioned on n, similarly a binomial, n, and this is 1 minus b. Okay, and so we also know, now given this information, we also know that x and y are going to be Poisson by the chicken and egg story. We also know that they are actually independent. And the critical thing here is that what is p? Well, this p here, we can decipher it by saying, what's the, actually let's write, I think the best thing is just to write out all the information. So what do we have? Well, we have people that are arriving to the store, and so the probability of sinister, let's set that to s, that we know is 10%. So that's 1 in 10. And the probability of dexterous, so that's d, that's 9 in 10. Okay. We also know that if they are sinister, what's the probability of them buying? Let's just call this b. That we know. Let's see, where is this information? So we know that 10% are sinister. Half of the sinister customers make a purchase. So half make a purchase. And if you are, call this d, dexterous. Conditioning on that, what's the probability of buying then? That's only 1/3. So 1/3. Okay, so we know that by so what's the probability of people buying? Well, P is now the, by the law of total probability, is the probability of buying conditioned on S, and the marginal, then the probability of being buying but being dexterous is like so. And so what we just plug in these numbers. So we have 1/2 times 1/10 plus 1/3 plus D, which is 9/10, like so. Right, and just calculating and simplifying this, we'll see that this ends up being 0 times 35. Okay. Now, given that we know this probability, we also can write by the chicken and the egg story. So I'm going to say the by chicken, well, let's just write it above, by chicken, egg, and those are the previous exercises. We know that X is distributed marginally as a Poisson, P times lambda. And Y is Poisson 1 minus P lambda. And in this exercise, we know what lambda is. It's 100. So this term will be 0.35 times 100, and that is 35. So in this particular exercise, X is going to be Poisson 35, and Y, whoops, sorry about that, Y is going to be Poisson 65. And so now on this certain day there are 42 people, so conditional on this information, now we are asked what is the probability of X that people buy, given that we know that Y is 42. Okay, this is a little ugly too. Let me rewrite it, 42. So then by the chicken and the egg store, we actually know that X and Y are independent. So this information doesn't do much for us. Well, it does basically nothing. So this is just the same thing as P, the marginal of X. And that we know is the probability of buying and that is probability of buying times lambda, and we know that this probability of buying times lambda is 35. That's 35. So we have that this whole thing simplifies to 35. Well, that was an ugly 5. E minus 35 x factorial for, we know this to be true for all x 0, 1, 2, etc. That is, in fact, the probability asked for. Conditional PMF is basically the marginal, simplifies to the marginal because of the chicken and egg problem.